This is chapter 5, polynomials and factoring. This is a super important chapter in algebra, in elementary algebra. This is the one chapter where you will get all of the information that you need to be really good at factoring. It's an essential skill as you move on in the math sequence into Math 89, Math 90, and if you're a STEM major, which you should be, then moving on along the path to pre-calculus and calculus. So super important skill, factoring. How I think of it is, back in the day, you probably learned prime factoring way back when, like 10, so let's take the number 10, and how do you prime factor that? So how do you factor it into numbers that multiply to be 10, and they can't be broken down any further. So we know 10 is 2 times 5, so that's the prime factorization of a number. So whatever we did with the number, we want to do something similar for polynomials. We want to break them down into a product of other polynomials, which are prime. They can't be broken down any further. So that is the idea behind factoring. So 5.1 eases us into this. So this chapter, each section is going to have a skill or two that you pick up on factoring, and towards the end of the chapter we put it all together and we go ahead and see which technique do we use when. So going chapter by chapter or section by section, you want to keep in mind, why are you going ahead and using this technique of factoring? So 5.1 is our introduction to factoring. So I begin with a problem. Number 1 is 8x plus 24. So our number 1 technique of factoring always is there a greatest common factor? So if I look at 8x and 24, is there a number that divides into both of these, and it's the largest such number? So when I look at it, of course there is. 8 is the greatest common factor. 8 goes into 8x, it divides into it evenly without a remainder, and 8 goes into 24 evenly without a remainder. So initially you could write the problem like this, 8x plus 8 times 3. I only do that for the first problem, but you are welcome to write it for the other problems as well. So if it's a common factor, you can factor it out. There is only one 8 in common because there's a single 8 here and a single 8 here. So you factor it out. So I write it on the outside. It's called anti-distributive. It's the opposite of distributing. So I pull it out. Then in parentheses, what am I left with? If I factor out this 8, I'm left with an x. Copy down the symbol in the middle, which is plus 3. If I factor out this 8, then what am I left with? It's just a 3. So my answer would be 8 times the quantity, so that's in parentheses, x plus 3. These parentheses are absolutely necessary. There is only a single 8 in common. There aren't two 8s in common because there's only 8 goes into this and only 8 goes into this. That is the largest such number that goes into both of those. So if you're thinking it should be 64, it should be 2 8s, that is incorrect because 64 does not divide into 8 and 64 does not divide evenly into 20. 24 doesn't divide into 64 evenly. If I distribute, so you can double check, so I get 8x, and I distribute the 8 to the 3, and I get the 24. And for the first couple of problems, I do check. You are welcome to check on all of these problems. The neat thing is you can always double check to make sure you got the correct answer. So when I go ahead and distribute, I do get back the original. But my answer is 8 times the quantity x plus 3. That is in factored form. It has been written as 8 times another polynomial which can't be broken down any further. So factoring means to write it as something times something else, or many factors multiplied together that can't be broken down any further in polynomial terms. So there is no common factor here between the x and the 3. That is the furthest you can go ahead and factor it as 8 times x plus 3 in parentheses. So we'll practice a little bit more. So problem number 2 is that 3x squared plus x, and I kind of scan this, and again I look for the greatest common factor. So it looks like x divides into 3x squared and x divides into x. So for me that would be the greatest common factor. That's the greatest such polynomial that divides into both of those at the same time. So I rewrite it as 3x times x plus 1 times x. So again, if I do anti-distributive, so I pull out or factor out the x, Then in the first spot, I will be left with 3x, so that's where that's coming from. In the next spot, I will be left with a 1 as a placeholder. It's not going to be nothing because when I distribute it back, I have to ensure that I get back the original. So here's my double check. When I distribute, I do get the 3x squared, and when I distribute, I do get the plus x. So this would be my final answer. There is no other common factor. And this is as far as you can take x times the quantity 3x plus 1. So the parentheses absolutely necessary. The order is debatable. I could write it as parenthesis 3x plus 1 and then times x on the outside. So order doesn't matter, just like for multiplication. 2 times 3 is the same as 3 times 2, so the order does not matter. So this is your number 1 technique of factoring. You factor out the greatest common factor. Let's take a look at another example. So in example number 3 is a minus 5y squared minus 10y. So getting a little bit more complicated. So I want to look at a factor that goes into negative 5y squared and the minus 10y, and it's the largest such factor. So if I write minus 5y times y, and here's a minus 5y, it looks like 5y is the greatest such factor. You can break it down into number piece and number piece. So what goes into negative 5 and negative 10 at the same time, and it's the largest such number? It would be negative 5. Okay, so you can get the number part. What about the y's? I've got y squared here and just one y here. What's the largest number of y's in common? Just one of them. I have 2 here, 1 here. What's the largest number in common? Just one of those. So that's how you could get the greatest common factor of minus 5y. So minus 5y times y gives me negative 5y squared. Then minus 5y times 2, that would be another way to write 10y. And again, I'm just writing it this way so I can see what the greatest common factor is. It is negative 5y. I think most of you would agree. It's negative 5y. So I factor it out, anti-distributive property, or the reverse of the distributive property. So when I factor out negative 5y and take it out, what am I left with in the first spot? Just a y. I took out the negative 5y in the next spot. That's going to leave me with a plus 2. Now, the sign, you factored out the negative, so it must leave behind a positive 2. And here's my double check. So yes, I do get back the original. So that is optional. I do encourage you to check it on the side, but the boxed number, the boxed quantity is my answer. Negative 5y times the quantity y plus 2. Again, order doesn't matter, but it looks awkward if you write it the other way, so I would prefer it written in this order. Negative 5y times the quantity y plus 2. So let's move on to another problem. So these just get a little bit more complicated. We're building on the fundamentals, building on problem number 1. So I've got a 16a to the 4th minus 24a squared. So by the middle of this section, I'd like you to be able to do it without breaking it apart. But if you have to break it apart, that is fine. So I look at the numbers, 16, and look at 24. What's the largest number that goes into 16 and 24 at the same time? So I would say the largest such number is an 8. You know, I'd work my way up. I'd say, oh, 4 goes into both of those, but is there something larger? Of course, 8. 8 is something that goes into both of those. Then you look at the a's. I have 4 a's here and 2 a's here. It's the most number that's common. Just 2 of the a's, so just a squared. So if I factor out 8a squared out of this, so in a sense I am dividing this by 8a squared, so if I factor out an 8 out of the 16, I would be left with a 2. 16 divided by 8 gives me 2. If I factor out a squared, and I had 4 of them originally, so if I take away 2, I'm left with 2 of those. So the first spot is just going to be 2a squared. If I factor out an 8 out of the 24, I would be left with a 3. 3 times 8 is 24. Then I factored out a squared, so all of the a squareds are gone. So it would be 8a squared times parentheses 2a squared minus 3. There are no common factors here, so 2 and a 3, or 2a squared and a 3, there's no common factors. So this is as far as I can take it. That's your double check on if you've truly factored this or not. So here's my check off to the side. When I distribute, do I get back the original? Whoops, I accidentally wrote an 18. I should have written a 16. So yes, that should be 16, a to the fourth minus 24a squared. I apologize for that. So that should be a 16. So I do get back the original. So taking a look at problem number 5. So problem number 5, like I said, these problems are building. So I've got x to the fifth, y to the fifth, plus x to the fourth, y cubed, plus x cubed, y cubed, minus x squared, y squared. So I focus in on the x's. There's 5 x's here, 4 here, 3 here, 2 here. What's the greatest number in common? Just 2 of them. What about the y's? There's 5 of them here, 3 of them here, 3 of them here, and 2 of them here. What's the greatest number in common? Just 2 of them. So if I had originally, so that's my greatest common factor for all 5 terms, or all 4 terms, it has to be for the entire polynomial. So if I had 5 x's and I took out 2 of them, I should be left with 3 of them, okay? So if I had 5 of them and I took out 2 of them, I should be left with 3 of them. Similar type of thing with the y's. I had 5 of them, I took away 2 of them, so I will be left with 3 of them. So that leaves in the first spot x cubed, y cubed. Copy down the symbol in the middle, that's the plus. I originally had 4 x's. I took out 2 of them, so I should be left with x squared. The y cubes, I took out 2 of them, I'm just left with a y. Do a similar thing for the next term, plus I had 2 x's, 2 y's, so I will be left with, I took out 2 x's, 2 y's, I'll be left with 1 x, 1 y. Move on to the next term, minus, I took out all of the x's, I took out all of the y's, so I will be left with a minus 1 as a placeholder. Remember, when I distribute this back, I should get back the original. So that 1 is a placeholder, really important. You're not left with a 0, you're left with a minus 1. And of course, you can distribute and double check your work off to the side. I did not, but you could, and you would double check. But your boxed quantity is your answer. So let's move on. These get a little bit more complicated. So this, number 6, is b times the quantity b plus 5 plus 3 times b plus 5. So I look at the first term, which is right here, and the second term, which is right here. So they're connected by addition. What's common? Oh, I have a b plus 5 here, and I have a b plus 5 here. So b plus 5 is my greatest common factor, so I factor it out. If I pull out the b plus 5, what am I left with? I will be left with just this b. If I pulled out that b plus 5, which is right here, what am I going to be left with? Just a 3. There is only one b plus 5 in common, because otherwise I would have a squared here if 2 of them were in common, and there aren't 2 in common, it's just 1. So b plus 5 got factored out, okay, just one of them. So b, I factored out the b plus 5 out of here and out of here, just one of them. So I'll be left with b plus 3. When I go ahead and distribute, the b distributes here, so I would get the b times b plus 5, plus the 3 distributes to here, b plus 5. So I do get back the original if I double check. The clouded answer, that is my final answer. There are no other common factors. This is as far as we could take it. Number 7 is very, very similar. So I've got an x squared times x plus 3 minus 7 times x plus 3. Look at the overall problem. Here's the first term. Here's the second term. What's common in both of those? I have just one of those x plus 3's in common. It doesn't say squared anywhere. There's just one x plus 3 that's in common. So factor it out. If I factor out the x plus 3, what am I left with in this spot? An x squared. Copy down the symbol in the middle. X plus 3 was factored out right here. It's going to be a minus 7 in that second spot. And again, I could double check. X squared would get multiplied by this x plus 3, and the minus 7 would get multiplied by the x plus 3 in my double check. Are there any other common factors here with these polynomials? No, there's nothing else in common that I could factor out. So that's my final answer. So these two problems are leading us into one of our next techniques of factoring. It's factor by grouping. So factor by grouping relies on this idea it'll be one of our intermediate steps. So factor by grouping, usually you have 4 terms, okay? So 1, 2, 3, 4, that's a big clue that could possibly be a factor by grouping problem. So the directions in the system tell you factor by grouping if possible. So factor by grouping, typically you group 2 terms at a time. So your first guess is the first 2 terms and the last 2 terms. I just underline them. So these are grouped. So I just focus in on this group. What's a common factor between x cubed and 2x squared? Oh, 2 of the x's are in common. So x squared is definitely in common. So if I factored out x squared out of the first term, I'd be left with an x. If I factored out x squared out of the second term, I'd be left with a 2. So that would be the first term, just factored. And then plus, so copy down the symbol in the middle. What's common in the last 2 terms? Well, of course, 5 is common. So 5 times x plus 2, because if you factor out the 5, it's going to leave behind the x plus 2. We're not done because this is still connected by addition, so that's really important to show this intermediate step. So we take a step back at the entire problem. So this is like problem 6 and 7 over here. What's common in the entire problem? What is the greatest common factor overall? I have an x plus 2 here, and I have an x plus 2 here. So that is common. So I factor it out. There's only 1 in common because this is only to the first power. In order to take out 2 of them, you would need x plus 2 squared, and we don't have that. So in the first spot, I'm left with x squared plus, copy this down, plus the 5 because x plus 2 got factored out. So it has this original polynomial, which is connected by addition, been written as something times something else, and those somethings can't be broken down any further. Of course, it's written as x plus 2 times the quantity x squared plus 5. There's nothing common here, nothing common here. So these are what are called prime polynomials, just like there's prime numbers, like 2 is prime, 3 is prime. These are prime polynomials. They can't be broken down any further. So this is as far as this problem goes, and we have done our first factor by grouping problem. I'm going to do a few more. So here's number 9. Number 9 says, okay, now it's 4x cubed minus 20x squared plus 3x minus 15. 1, 2, 3, 4 terms. Big clue is factor by grouping. So group the first 2 and then the last 2. This usually works. On a rare occasion, you might have to rearrange. If your factor by grouping is failing, you might have to rearrange the terms, like swap 2 of them, and then it works. But on this one, I don't have to rearrange. So I focus in on the first 2 terms. What's the greatest common factor between 4x cubed and a minus 20x squared? Oh, 4x squared is common. So if I take 4x squared out, then I'm left with just an x, because I took out the 4, I took out 2 x's, I'm left with just 1x. Copy down the symbol in the middle. I took out a 4x squared, so I'd be left with just a 5. And again, you can double check by distributing. Copy down the symbol in the middle. What's common with 3x minus 15? Oh, 3 is common. So pull out the 3. I'll be left with x minus 5. Overall, take a look at the entire problem, which is right here. What is common? Oh, x minus 5 is common. So if I factor out x minus 5, just one of them, because it's only to the first power, what am I going to be left with? Oh, 4x squared right here plus 3, because x minus 5 got factored out. It is the greatest common factor. Has our original problem been written as something times something else, and those somethings don't have any common factors? They're, in a sense, prime? Yes, for sure. These are prime. There's no common factors. So my answer would be x minus 5 times 4x squared plus 3. Parentheses are absolutely necessary. The order can be swapped when you put them into the system. So it could be 4x squared plus 3 first, and then x minus 5. Because remember, as I just said a couple minutes ago, order of multiplication does not matter. Few more problems. So this is x cubed plus 5x squared minus 21x minus 15. So I underline the first 2 and then the last 2 just as a default. What's common between 7x cubed plus 5x squared? Nothing common between the 7 and the 5, so those remain. just 2 x's are common, so that would be x squared. So factor out x squared out of 7x cubed. I took out 2 x's, so I'll be left with 7x. Copy down the symbol in the middle. I took out the x squared sitting right here, so I'm just left with a 5. Copy down the -3, or copy down the minus. And then what's common here? What goes into 21 and 15, and what's the largest such number? It'd be a 3, so -3 is what I'm pulling out. So this does have a negative, so we have to be careful. So I pulled out the negative, and I pulled out a 3, so I'd be left with 7x. And then in the next spot, I pulled out a negative, and I pulled out a 3, and out of the 15, I'd be left with a 5, because 15 is 3 times 5. When I distribute it back, I would get the -21x, and I would get back the -15. So that's a double check that I did this correctly. Take a step back, look at the whole problem. What's a common factor? Oh, 7x plus 5 is common. So if I factor that out, I just wrote it over here. What am I left with in this first spot? X squared. 7x plus 5 is factored right here. And what am I left with in the second spot? A -3. And 7x plus 5 is factored out. So this is the 7x plus 5. Again, order doesn't matter. It could be written as in the opposite order, 7x plus 5 in parentheses times x squared minus 3 in parentheses. Parentheses are absolutely necessary. Let's take a look at another factor by grouping problem. So it's x cubed minus x squared minus 2x plus 5. So I know x is common here, but in the next set, there's nothing in common. So factor by grouping in a sense fails, and again I would try to rearrange these terms. And what happens is, even if you rearrange those terms, it's not going to be factorable by grouping. So not everything is going to factor, just like the number 3 doesn't factor. It's just 1 times 3. So that happens with some polynomials. So not every polynomial is going to be prime, but this is called a prime polynomial. So we just say not factorable by grouping. So just be aware, not everything is going to be factorable by grouping and so forth. So that was your introduction to factoring 5.1. Good luck with this section. It's your introduction, so enjoy it. So section 5.1.